intramolecular versions of the Aldol and or Claisen reaction are useful in making rings, and as we've previously described, 5 and 6 membered rings are highly favored. Starting with the Aldol, the initially formed beta hydroxy ketone can also provide the alpha beta unsaturated enone. So for example, this molecule, heptane 2,6-dione, which is called a 1,5-dione, because the two ketone groups are 1,5 from each other. In an effort to help you see how it cyclizes, it's, in my opinion, very helpful to redraw it so that you can see the proximity of the alpha carbon of one carbonyl grouping can be in close proximity to the carbonyl as it wraps around. As is customary of Aldol, we would use a base like ethoxide to form an enolate here, and then the enolate would condense onto the carbonyl as in our standard Aldol, and this would provide that beta hydroxy ketone, and with mild heating that can of course be dehydrated to the alpha beta unsaturated enone. Analogous reaction between this ketone aldehyde would provide, by similar reactions, that beta hydroxy ketone, and then dehydration would form that cyclohex enone. These enone derivatives are very good amical acceptors, and that's a reaction we're going to study coming up, in that we've created this 4-atom region that's highly conjugated, and we can do additions to either what we're going to call the 4th or the 1,2. So these are going to be good acceptors for the Michael reaction. And just to practice a little bit, this hexane 2,5-dione, which is a 1,4-dione, analogously, it helps to redraw it. And then you can see that that carbon alpha to this carbonyl is in proximity to that carbon of that carbonyl. And if we can cyclize, we'll make a 1, 2, 3, 4, 5-membered ring. So again, with base, we're going to make an enolate down there. Of course, it wouldn't matter which way. And then the enolate condenses on the ketone. To make that beta hydroxy ketone, which could easily be dehydrated to that cyclopentenone derivative. And if we start with a ketone and an aldehyde, analogously, we're going to generate that beta hydroxy ketone, and dehydration would afford that enone. For the intramolecular Claisen reaction, which is also called the Dieckman condensation. We'll begin with diesters. And the diesters again need to be in proximity to each other such that a 5 or 6 membered ring could form. An ester such as that, which has the 2 carbonyls of each ester group, 1, 2, 3, 4, 5, 6 from each other. They're derivatives of an acid called adipic acid. Depending on what the R group is, you could have diethyl adipate or dimethyl adipate, etc. The condensation in this case is a Claisen, and it's called a Dieckman if we're going to cyclize. And the cyclization, envisioning it, is going to occur between those 2 carbons. So to help see that better, of course, it's really helpful to redraw that ester. Like so. So 1, 2, 3, 4, 5, 6 total carbons. 1, 2, 3, 4, 5, 6 total carbons. And I'm representing this one right there and this one right there. And then you can see, as we've seen a few times now, if we treat this diester with base, we're going to get an enolate formed down here, and then the enolate can condense onto this ester. And again, an abbreviated mechanism would be base, enolate, and then enolate, attacks, and then as the carbonyl reforms, kick off the protonated alkoxide or an ethanol molecule. And that's going to result in that type of cyclization. So it's a cyclopentane ring and flanked by an ester, and of course alpha beta. So it's a beta keto ester. So we're calling this alpha and that beta. And that's an example of a beta dicarbonyl compound. So Claisen cyclization, aka the Dieckman reaction, makes beta keto esters. If we were to begin with analogous ester with one more carbon in the chain. And do the same reaction. We would be condensing this carbon onto that carbon and making a 1, 2, 3, 4, 5, 6 membered ring. So now if we want to redraw it, with this carbon being that one, 1, 2, 3, 4, 1, 2, 3, 4, 5, and OR. And again, highly abbreviated mechanism would be connect the alpha carbon of one ester group and then as that comes back, kick off the OR, resulting in that beta keto ester. So 5-membered and 6-membered rings from the intramolecular Claisen afford beta keto esters. And these are going to be particularly useful because the alpha carbon in between the ester and the ketone is now doubly alpha, and it's got it even more acidic than a singly alpha hydrogen. So these are going to be very useful when we do acetoacetic ester synthesis and malonic acid synthesis. And that's what's coming up next.